Alright, ladies and gents, so this is the question we're going to do today. You guys have the question already, so yeah, anyways. April 22, so I have some assistants here with the video recording. Long time we know, seen or hear from each other. Well, I'm not seeing you, but you're seeing me. Alright? You're hearing my voice. Long time, none of this is happening. But yeah, we'll have a mask, but it will sound too muffled. So we're not doing that. Alright? Standing 6 feet, sir. Yeah, see it good?
Yeah, I'm not turning it, so.
Oh, I have to turn it, alright? So yeah, you have to turn it full. Oh, but you're going to just keep it so now, so that you don't have to turn it. Alright, so we have this question, like I said, Marion Road from A to B. So it says the graph shows the journey of two cyclists. Alright? So the graph here, I see a line, see this path here and see this next path, two cyclists. It says Marian and Nathan, who traveled between two towns, A and B. So there are two towns here. There are two towns and there's going to be a distance between two towns. This is the distance axis and this is the time axis. So the cyclists are traveling a distance as time progresses. Yeah? Yeah. So Marion Road from A to B. Marion Road from A to B. From A to B. And it says Nathan Road from B to A. I wonder which one of them would be Marion and which one of them would be Nathan. First time using this question, Mr. Cameraman, Mr. Videographer. You tell me which one of them, the blue or the red, which one you think is Marion? It says Marion Road from A to B. Which one do you think is Marion? The red or blue?
The blue.
The blue. It is, yeah, it must be. See, it says A, C, D, and B. It says they are the graph. Alright? So from A to B. So this is Marion. The blue is Marion. Let me just write the name really quickly on it. Marion. And therefore this is Nathan in red. Alright, here, real quick and fast. Nathan. Alright? Cameraman hasn't done math in many years.
Many years.
So we'll have that going on here. Marion A, C, D, B. B is how far away, by the way? 41 kilometers. So B, so from A to B, 40 kilometers. I can actually even write B right here as well. It's 40 kilometers from A to B. So we know that this is B. So this is B, and down here says A. A to B. A to B. You see that? It only spread like this because you need to see as time progresses. But really and truly what is happening is Marion Road in that direction and Nathan Road from B to A that direction. Simple. But we have to have it going like that because we need to see as time progresses. Alright? So yeah. It says determine the length of time in hours that Marion rested. So this is Marion. So Marion at this time 0 hours. You don't really get the exact time of day, it just says 0. So start 0. You go da 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 da. So this is 1 hour later, 1 hour later, this is where Marion reached. 2 hours later, Marion is 15 kilometers away. 2.5 hours later, Marion is still 15 kilometers away. 3 hours, Marion is still 15 kilometers. Obviously, Marion has stopped. Marion has rested for this section right here from 2 to 3. So, length of time Marion rested, 1 hour. So, A part 1, 1 hour. A part 1 hour. Marion rest. Alright? Next thing, the distance in kilometers between the towns A and C. This is town A, and the C here, boom, C is right here.
So that would be 15 kilometers.
Cameraman, wait, you got yourself. 50 kilometers. Simple boom bap. Next question, part 3. Marianne's average speed. Whoa, we need to determine Marianne's average speed over the entire journey. Many years, you know, what's speed? You know, the formula for speed. We'll have, look at the variables that we have. What is on the y-axis? Distance. What is on the
time.
x-axis? Over time. So speed is equal, remember right, it's part 3.
Speed is equal to distance over time.
Simple. Boom bang. Speed is equal to distance over time, which is why when you look at your speedometer when you're driving, the speed gauge, it is kilometers per hour. So if you're driving 60 kilometers per hour, 70 kilometers per hour, km distance per over hour. Distance time. Distance over time. Kilometers per hour. Distance time. Alright? Distance in kilometers over time, which is hours. So they want to know the average speed. So let us look at this. The total distance that was traveled by Marianne was from here to here, which is 40 kilometers. So you look at the total distance, right? The total distance, which is 40 kilometers, and you divide that by the time it took. We know business says she don't want to stop, a fear business that she stopped, alright? The time though, 5 hours. Alright, because you know in reality when you're driving, you stop at stoplight, you slow down, you speed up, all sorts of things. So at different times you're going at different speeds. But when somebody asks you, what's your average speed? So you drive from Kingston to Mobile, you check the distance and then you check the total time and you divide it. Alright, even though you had variable speeds at different points. You stop sometime and sometime you clock all 120 kilometers per hour, which you shouldn't. Alright? But you do the maths, 40 divided by 5, that is 8 kilometers per hour. Sometimes you'll see it written as 8 km, 8 to the negative 1, 8 to the negative 1, same thing, alright? It's per hour. So that is part 3. Part 4, the distance in kilometers from B, the distance in kilometers from B where the cyclists met. Now I ask you, where do you think the cyclists met on this diagram? So I want to know the distance in kilometers from B where the cyclists met.
From B.
From
that would have be 40 minus 15.
Oh. That's good. Why minus 15?
Because it shows where they intertwined right there.
They intersect right here. So this is where they met. This is exactly where they met.
And on the y-axis, that is
15.
15.
And B is 40. So 40 minus 15, whatever that is. What about 25?
Yeah, about that.
So they met at 40 minus 15, 25 kilometers. Simple boom bang. Next thing, number 5, the time Nathan took to complete the journey. The time Nathan took to complete the journey. Well, Nathan started right here at 0.5 hours, and he ended right here at, what is this, 3.5 hours. So the duration is going to be 3.5 minus 0.5, which is 3. Simple boom bang. Nathan's duration, so Nat's duration is equal to 3.5 minus 0.5 equal 3. 3 hours. Alright, what the next question? Part B says, if Nathan began his journey at 10 hours. Nathan began his journey at 10. So this is actually 10. Let me rub this one right here. So this is 10 o'clock. 10 a.m. Alright? 10 hours. If Nathan began his journey at 10 hours, determine the time Marianne started her journey. Notice clearly. So this is 0, this is 1. This is 10. And this is 10:30. True?
Yes.
And then this would be 9:30 right here. So because from 0 to 1, this is a 1 hour bracket.
Yeah.
9 So this is, if halfway is 10, if this is 10, this must be 9:30, 10:30, which means this is 11:30, which means this is 12:30, which means this is, and so on and so forth. 1:30, 2:30, so on and so forth. So if this is 10, 10:30, 11, 11:30, 12, 12:30, this right here, so it's going to be 1. Alright, so on and so forth. So if Nathan began his journey at 10, determine the time Marian started her journey. Marian started at 9:30. So B part 1, 9:30. And part 2, it says the time Nathan reached town A. So this is Nathan starting from town B, going this direction to town A. He reached at 1 o'clock. No, so?
Yeah, 1 o'clock.
1 o'clock. So he reached at 1 p.m. 9:30 a.m. Done. That's it. Thank you, man.